Hello, everyone. My name is Alexey, and I work at ChainSafe. At ChainSafe, we are passionate about building open source software. One of our biggest contributions to the Filecoin ecosystem is Forest, one of the 3 Filecoin node implementations. Today, I'll share the story of how we care for Forest and how the new tools we built help the entire ecosystem move faster and more efficiently. Forest is written in Rust and is highly efficient. Still, like any complex system, without proper care, it can gradually degrade. According to Slavic mythology, in every forest lives a leshy. A leshy is a spirit who guards the forest, nurtures it, and helps it flourish. He wants forest to be the most efficient, and he wants to always keep track of what happens in forest and protect it against changes that could affect its health. We decided to assist Leshy in his mission to keep forests healthy and efficient. Our first step was very simple. We built a speed testing tool that made one request per method and showed both the response speed and any errors. We originally built it while working on full Ethereum RPC support, when we needed a quick and reliable way to check if our local node responded correctly and fast enough. The final shape of the tool was inspired by Michael Saller's RPC benchmarking tool, but we focused on supporting parallel requests and custom RPC URLs. We added several well-known public RPC providers and field to enter custom RPC URL. Custom URLs are saved in local storage, allowing users to easily enable or disable them without re-entering the information. But it was obvious from the very beginning that single request speed testing wouldn't be enough for our needs. Real-world applications don't just make one call, they make thousands, sometimes millions. We needed something bigger, something that could simulate real loads, track performance over time, and allow us to compare different node versions side by side. That's when we decided to build a proper benchmarking tool. I'm glad to introduce the Filecoin benchmark suite, a tool we built to measure the performance in real-world, consistent way. Under the hood, it uses K6, Grafana's powerful benchmarking engine, and it's easily customizable since it's written in JavaScript. We designed it to be node agnostic, meaning it could be used to compare Forest with Lotus, Lotus with Venus, and so on. Our current implementation covers the top 45 RPC methods. The tool can be used in automated tests or manually, helping node developers and independent researchers analyze the performance of different implementations, or even different versions of the same node for performance regression testing. The benchmark suite is also very flexible when it comes to output. You can export the benchmarking results directly into your existing monitoring system, such as Amazon CloudWatch, Datadog, or Grafana Cloud, without additional setup. This makes it easy to integrate performance tracking into whatever monitoring stack you already use. It also prints results directly into the terminal, which is perfect for developers doing fast local testing. Developers can easily see average information, minimal requests, maximum, and so on. But we usually use the benchmark suite with Grafana Cloud to have the opportunity to analyze time series with high precision. Grafana Cloud allows us to compare 2 different runs, which we use to compare Forest with different implementations. In the benchmark suite, different RPC method calls are automatically marked with tags when results are sent to Grafana. These tags allow us to easily separate the performance data by method, so we can easily spot which RPC methods are working well and which might need optimization. Thanks to benchmarking, we managed to optimize some of our methods and achieve the level of speed and efficiency that we had never seen before. Right now, 39 out of 45 most popular methods in Forest are at least 2 times faster than in alternative implementations. Forest is so lightweight that it can even run on a cheap general-purpose AWS server or on a Raspberry Pi. By the way, if you will be on Field Dev Summit in Toronto, Josh from our infra team will be handling Raspberry Pi with Forest running on it, and you can interact with it and maybe get some POAPs. Thanks to its speed, Forest is the default choice for creating snapshots. When we last time measured the performance of Forest, it managed to create snapshots in 30 minutes, while in Lotus it took 2.5 hours, as far as I remember. And we are working hard to make the remaining methods blazingly fast. I can already state that for some use cases, Forest is the most efficient Filecoin node implementation. We want it to be used widely by the community, and I believe that now it's a very good fit for RPC providers. Forest already supports around 90% of the RPC methods implemented by Lotus and 100% methods defined in the Common Node API. Forest also works with the Lotus gateway, meaning that for RPC providers, the transition could be seamless. If needed, Forest can work in parallel with other implementations, allowing operators already to save some money on infrastructure while waiting for Forest to support all methods that they need. We want the entire ecosystem to move toward greater efficiency. That's why we open source the benchmark suite and invite anyone interested to participate. By covering more methods, integrating it into their workflows, improving their nodes, their implementations. The speed testing tool is also open source and can be already used to check RPC method support of different RPC providers and measure response speed of RPC providers. In the future, this tool will share the same set of methods covered the benchmarking suite, and will provide developers with better insights on network lags and call data details. Thank you very much for your attention. You can follow ChainSafe for me on X and contribute to benchmark suite and speed test repositories. Let's keep making Filecoin faster and stronger together. Thank you.